All right, welcome back, guys. Now it's time to look at the first heuristic, and this is all about variable selection. In particular, we're going to look at a principle known as the first fail principle and how we can instantiate it with something quite simple as a heuristic, which is the domain size. So let's go. Now, the basic idea of the first fail principle is that to succeed, try first where you're most likely to fail. And that's an idea that's not necessarily intuitive at first, but it relies on this concept that since all variables eventually need to be fixed, if there are no solution in the node, you'd rather detect that as quickly as possible so that you don't waste your time exploring this subtree below that node, because that's wasted effort. So how do we do that? Well, there are several ways, and we're going to look at a variety of options that all abide by that principle. We'll start with min-dom, which is the simplest, but we'll look at dom plus dog, dom over dog, dom with wdog, impact, activity, last conflict search. So we'll touch on a few things. But let's start with the easy stuff first. Now, min-dom, the idea is to select an unfixed variable that has the smallest domain size. Now, the heuristic was shown to work quite well, and it minimizes the size of your tree. Remember, we want small trees, right? And to just make some sense out of this, imagine that you have a problem where you have two variables, x1 that has only 2 values, and x2 that has 100. Now, clearly, if you branch on x1, whatever value you pick, it will be fixed. It will have only one value, and it's likely to trigger far more propagation. Now, if you were instead branching on x2, you would fix it to one value, but it would not necessarily have as much of an impact on the other variable, right? You wouldn't have as much propagation. So the trick is go for the smallest domain first. And that can work if we remember the Queen's example we've been looking at in the past is here again. And you see here that the few lines of code we see here at the top are basically showing us a very simple idea. We pick a variable, QS, which happens to have the smallest domain size, right? So we're minimizing the size of the domain for queen I, and that's specified by the second first-order function being passed in. Now, if we have none, means all the variables have been fixed. Otherwise, we pick the smallest value in the domain. Notice that this is a variable and a value selection. Min-dom refers to that value being the smallest in the domain. And we create a branching scheme that says either QS is equal to V or it's not equal to V. So pick an unfixed variable, right? That's the first closure. That minimizes the size of the domain, smallest domain, and then pick the smallest value in the domain. Min-dom. That's the idea. And that's all you need as a branching scheme for actually getting going. Now, there are others, and we're going to look at them in the next video. See you next time.